Hi guys, today we're going to be talking about shadows and images. As you can read in here, there's no formula for how to solve our problems, but the problems are done by proportions using similar triangles. So let's see, if we have a light source right here, and we have an object, let's say that's you, and if you are between a light and a wall, you are going to have a shadow. So there we go, there's our sharp shadow. We can figure out how tall the shadow is going to be just by knowing the distance between you and the light, of course your height, and the distance between the light and the wall in which the shadow is going to be projected. So if the distance between the light and you is 2.0 meters, let's say that your height is 1.70 meters, which is average, and the distance between you and the wall is going to be 3 meters. So we have to find how tall the shadow is. There's our x in there. So our proportions, we can just write the x's over the y's or the y's over the x's. In this case, I'm going to write the distance between the light and you will be 2 meters is to your height. There's your y, 1.7 meters is to equals 5.0 meters. Why 5? Because you are adding the distance between the light until you get the wall, so the shadow. So that's going to be 3 plus the 2 plus the 3. That's going to be your 5, and that gives you an x amount of meters of how high the shadow is going to be. So we solve this proportion, so it's 1.7 times 5.0 over 2.0, that's going to be 4.25, and we are using two sig figs in here, so x is going to be equal to 4.3 meters. Let's go to our next example. And now, instead of having same thing, now how are we going to have our shadows? We have a large light in there, and we have an object, and we have as you've seen in shadows, you have something where you see a sharp shadow. That's called the umbra or the full shadow. But also you've seen like the shadow is a little bit lighter around, and we're going to call that the partial shadow or the penumbra. So that will be your partial shadow. Let's see how that's going to work. For example, we have now an object, and it goes into a pinhole camera. That's going to be a good homework for you guys to figure out what a pinhole camera is. It was old cameras, but figure it out. So we have an object that's 10 meters high, and we have a distance between the object and the camera of 7.0 meters. And the camera has a length of 30 centimeters. We want to know how tall is the image that's going to get projected into the pinhole camera. So this is our focus point right here. So we're going to say that 10 meters is to 7 meters as x over 0.30 meters because of sig figs. Again, sorry about that. So we can just pretty much solve for x by multiplying 10 times 0.3 and dividing that by 7. Perfect. Now let's go into a couple of problems. So we have calculate the size of an image produced on a pinhole camera that's exactly like the one we had before. That is 10.0 centimeters long and a 5.0 meters high object is placed 15 meters in front of the camera. So there's your object, there's your camera that is going to be 15 meters away from the camera, and you know that the camera is 10 centimeters long or 0.1 meters, so we can figure out for x. So to write our proportion, we can say that 5 meters over 15 meters equals, and since 5 is the height, x is going to be the height as well, so that's going to be x over the length for the object to the camera is 15 meters, and now we use the length of the camera, so that's going to be 0.1 meters. So we just multiply 5 times 0.1 and divide that by 15, and that's going to be 0.03333, etc. And we are using 2 sig figs in here, so x is going to be equal to 0.033 meters. Excellent. Let's take a look at another problem. And now we have a linear object that is 2.17 meters tall. It's placed 0.75 meters from a small light source. And a shadow is produced on the screen, and that shadow is going to be 1.10 meters behind the object. And we're supposed to calculate the height of the shadow. So, same as the first example. Now we can say that 2.17 meters, so we are going to put heights on the top and lengths on the bottom. So that's going to be 0.75 meters on the bottom, and that's going to be equal to x, since that's our height, over, and that's going to be 1.85 because we happen to be adding the 1.1 to the 0.75. So that will be 1.85 meters. So we solve for x by multiplying 2.17 times 1.85 and dividing that by 0.75. So x will equal 5.3526. We have 2 sig figs in our final answer, so x is going to be equal to 5.4 meters. Great. Let's take a look at our last example. Now we have a circular object that has an area of 7.06 times 10 to the negative 2 square meters. Is placed 0.25 meters from a point source of light. Calculate the area of the shadow produced on the screen that is 1.0 meters from the light source. In this case, as you notice, we're giving the area. So first thing that we would have to figure out is the diameter of that object. So I know that area equals pi r squared, and that area is going to be 7.6 times 10 to the negative 2, and I have to solve for r. So r is going to be equal to the area, to the square root of the area over pi. There you go. So our calculated answer for r will be 1.55. So the diameter is twice that, so that's going to be 0.311. So since I know that diameter, now I can figure out, I know that the object is 0.25 meters from the object. So what I got to figure out now, and I know that the shadow is 1 meter away from the light source. So I just got to figure out that x. So x over 1 meter equals the 0.31 in diameter that we got over the 0.25. So x is going to be equal to 1 times 0.311 and divide that by 0.25. So x is going to be equaling 1.224. So that's the radius of the shadow. And the radius of the shadow, of course, is going to be half of the diameter, which we just calculated. So that's going to be 0.622. Now for the area of the shadow, now that's going to be pi r squared as well. So that's going to be 1.12 meters. And since we're using 2 sig figs, our final answer will be 1.1 square meters. And that's the area of our shadow. Excellent. I hope that this helped, and I will see you in class. Bye-bye.